This presentation will review Earth's temperature history and compare it to Earth's sea level history going back in time over a period of 550 million years. We'll do this by looking at 5 separate panels from our climate project. We're looking at the first panel. This blue graph you see here is the temperature graph, and in this particular panel present Earth temperature is represented by this line here, and the scale that associates with the temperature is this scale here. So 0 degrees is represented as our present temperature, and the plus values here and the negative values here indicate changes from present temperature average over time. This graph here represents the change in sea level over that same period of time. The sea level gauge is here. 0 represented by this thin blue line is the current level around the Earth on average, and these values on this panel go down to as low as minus 140 meters. And as we go back in time, you can see that sea level went down to about 120 meters below present value as temperature slowly went down to about 7 or 8 degrees Fahrenheit lower than our average temperature today. Here we've navigated to the second panel in our climate project. This panel covers a period of time from 20,000 years in the past on the left to 1 million years ago on the right. This blue-black graph you see here is the changes in Earth's temperature over that period of time. This black line you see here with the 0 on it is the average Earth temperature today. And this gauge here is telling you the deviations above and below our current average temperature. That the temperature changed as time went on. This graph above it is the sea level graph covering the same period of time. Its gauge is here. You can see it going from 0 or the average today down to about minus 140 meters. Notice that there are cycles in changes of the temperature. These cycles, which are called Milankovitch cycles, are basically affected by changes in the Earth's orbit as it goes around the Sun. And during this period of time these cycles basically happened about once every 100,000 years. And if you look at the average temperatures, you'll see that they tended to average below today's average temperature. However, during these peaks, which are called interglacial periods, which is where the temperature was at the warmest period as the Earth warmed and cooled the last 4 interglacials. And by the way, we're currently in an interglacial today in the modern Earth, but these previous 4 interglacials said peak temperatures that were all above today's average temperature. Quickly looking at the sea level chart, you can see that the deviations in sea level closely mirrored the deviations in the temperature chart. And I'll point out that for 3 out of the 4 previous interglacial periods sea level actually was higher than it is today. As indicated by these little red splotches you see here. For this interglacial here, the sea level actually ended up being 8 meters or about 26 feet higher than today's average. Before leaving this panel, I'm going to point out that the values that we have for both temperature and sea level have been derived from proxies. The temperature values here were all derived by looking at ice cores from both Greenland and Antarctica, where air bubbles in the ice gave indications of what the temperatures were at the time. The changes in sea levels here were determined by looking at geologic proxies such as different seashells and different types of rocks all around the world, which can be used to give a very accurate reading of where sea levels were over different periods of time. Here we've navigated to the third panel in our project. This panel covers a period of time from 1 million years ago on the far left to 5.5 million years ago on the far right. Note that the temperature fluctuations, temperature is this black graph here, the temperature fluctuations seem to go up and down on a shorter cycle. That's because of these Milankovitch cycles were averaging about every 41,000 years. They too were basically driven by changes in Earth's orbit. That became a little less defined as we get past about the midway point here. I want to point out that notice that during this time span Earth's temperature stayed predominantly lower than our average today, the average being represented by this black line. With respect to sea level, the fluctuations again closely mirror the temperature fluctuations. And note that sea level generally stayed below today's average until we get to about this point in time. Today's average is at the 0 point in this gauge here. The temperature gauge here is the same one in the previous chart, and you can see the 0 value going here for sea level, 0 being today's sea level, which is along this dashed line. Here I've navigated to the fourth panel in our climate project. Note that this period of time covered on the chart is from 5.5 million years ago on the left to 66 million years ago on the far right. 66 million years ago was when the dinosaurs were killed off when the asteroid struck the Earth. In this panel, the green graph here is actually the temperature graph. This black graph here is the sea level graph. Note that temperature again here's our gauge stays consistently above today's average, and at this point it's by quite a bit, almost 25 degrees Fahrenheit higher than our average today, averages being this black line here. With respect to sea level, notice that it starts out above today's value. Today's value is this dashed red line, and it too goes up quite a bit. And at this point here near the peak it's almost 400 meters above today's value. Again, today's value is this dashed line, and here's the sea level gauge. I'll point out again that the values here for sea level were determined by geologic evidence, being rocks and seashells. That also holds true for the temperature chart you see here. It was derived by analyzing geologic proxies. Here we've navigated to the fifth panel in our climate project. This particular panel covers a period of time of 66 million years ago on the left, to 550 million years ago on the right. And this panel, this yellow-red line you see here, is the temperature curve. The sea level is this red line you see here. Again, on the temperature gauge, this black line is today's average temperature. And on the sea level its gauges here, and you can see, and let me reposition my little thin blue line, you can see that today's sea level, which is represented by the 0, goes along here. I want to point out that these values for both temperature and sea level were also determined from geologic proxies. But I want to point out how there were significant differences, wide swings in both temperature and the sea level. Here again the temperature is a good 25 degrees Fahrenheit above present. Sea level, as you can see here, reached a good 400 meters above present value.